Welcome back to the Glacial Gold Hunter. Today we're going to be checking out the Mighty Mill. Now you guys have seen my video where I tried to make a ball mill. That kind of failed. It's still in the works, but I haven't got back to it yet. But in the meantime, I'm going to try out the Mighty Mill. Jason, the Flower Gold Wizard, he loaned this to me and said I could give it a try. And I'm going to be using it on this material right here, quartz. Now this big bag of material was given to me by my buddy Dean. He also gave me some hand samples of it. It comes from a quartz vein in northern Minnesota. Now Minnesota isn't known for having a lot of gold, but up in the northern part, there are quartz veins with gold in them. In the 1860s, there was a Lake Vermilion gold rush where they found gold in the quartz. Also up near Rainy Lake, there's actually gold mines that were produced in the Rainy Lake area on the Minnesota side, and then right over the border in Canada, there's a lot of gold mines. That's where a lot of our glacial gold probably came from. Now, I don't know much about this mine. I just know it's from northern Minnesota and it's kind of a backyard project. And they dig out the quartz, crush it up, and they find gold. Now, the gold-bearing quartz veins are found in greenstone belts. And if you want to learn more about Minnesota's geology and the geologic history, this is a fantastic book. This was actually the textbook we used for my Minnesota geology class, written by Richard Ojikangas. And it kind of shows the little maps of the greenstone belts, and it'll explain how that works. It very briefly touches on gold-bearing quartz, but as for an overview of Minnesota's geology and what happened and what types of rock you'll find, it's a good book. These roadside geology books are also very good. Not every state has one, but if your state does have one, it's a good resource to tell you what types of rock you'll find in different parts of the state. And it kind of goes through an overview of the geologic history of the state. Wisconsin has one. I wish the UP had one, but they didn't make one yet. Anyway, I'll post some links to these if you're interested in checking them out. And your library is likely to have these on hand as well. Now this bag here has already gone through a crusher, and it's pretty small. It's like pea gravel size, but that's still too big to pan. And that's where the Mighty Mill comes in. Now being that this machine has been used before, and I kind of want to do a little bit of quantitative analysis to see how much gold is in here, I'm going to take this machine apart and make sure it's nice and clean so we're not contaminating our samples. And there's just a little bit of dust in there. It's pretty clean. And this is what actually breaks the rock. These little chain clevises here, they fling around so fast that you just pulverize anything that goes in there and turn it to powder. So it's just a little 4-inch angle grinder attached to that. Proudly made in the USA. USA! USA! It's got this little counterweight trap door here, so put the rocks in and they don't fly out. And then when you want to get the material out, there's this little trap door here that opens and you can dump that material out. All right, let's see how this goes. This thing's kind of scary, so I'm gonna wear all my PPE. Whoa, it's still on. Whew. Told you it was scary. Whew. Okay, earmuffs, safety goggles. Put your PPE on before you plug it in, because I don't want silicosis. I'm gonna wear a respirator. They say this thing is pretty dusty, and quartz is silicon dioxide. It's like little shards of glass, so if you breathe it in, it's really bad on your lungs. So I'll wear this, and then we should be good to go. So I'm making a mess. Stuff's a little bit hard to dump in there easily, so I might need a tool. I don't know how fast this fills up. That was a few handfuls. Let's just look at it. Yeah, it looks like a few handfuls at a time, maybe. That's really fine, though. Yeah, that works really good. We could probably do more than that, but probably not a lot at a time. Yeah. Oh. This little cup about 1/2 full seems to be good. So that bag of material is gone through, and it's about, I don't know, 2/3 of a gallon bucket full. And that worked really well to turn it into powder. There's still some bigger chunks in there. I'll strain those out, but that's exactly what I wanted. I'll be able to pan that out and see some gold for sure. Now the other bags have a different size material. These are, I don't know, 1/2 inch, I suppose, 1/2 inch size pieces of quartz, so a little bit bigger. And this should still work just fine for that. I think this will take a piece up to 1 inch. But where this came from, they got a little bit of a mining operation up there, and they must have like a jaw crusher or something to crush it down to different sizes like this. I haven't seen it. This is just the material that comes from it. They also have some pulverized bags in there that I didn't see the first time I looked. I just saw the top section. So that's all ready to go. That's kind of nice, a little less for me to crush. But let's go ahead and try this a little bit bigger size and see how the Mighty Mill handles that. You know, my mom used to wake up every Saturday morning and make wheat bread out of wheat berries. And she had a wheat grinder that would grind the wheat into flour. It was called a whisper mill. It sounded a lot like this thing. You can hear it clinking around in there a little bit longer with that bigger size, but no problem. Still just as powdery. So that's a full gallon of quartz dust. Now one thing I'd like to do is test the Mighty Mill on some bigger pieces. This is a little bit too big, but I want to crunch them down to about that 1 inch size chunk just to see how it handles a hard piece of quartz like this. Now this is my own homemade rock crusher, and it works really good for breaking the rocks down, but not for getting it to that powder. So I'm going to break this down to those 1 inch chunks, and then we'll be good for the Mighty Mill. So just a few hits in that mill, and that's what it turns it into. Checking to see if I see any visible gold. No VG, but let's see how it works on pieces like this. Well, I'm pretty impressed with this thing. It's definitely not made for like big batches, but for pulverizing a few hand samples, man, that thing's pretty slick. It is a pretty clever design, just with an angle grinder. Now when we're prospecting and classifying material, it's pretty common that we'll find chunks of quartz. This piece came from my tailings pile, but you can see it's quite a bit different than this gold-bearing quartz. This is pure white and clean. This is dirty and full of other stuff. And that other stuff is important. It's easy to get silicon dioxide to go into solution. It's difficult to get gold to go into solution. So all these other elements, all these other minerals, the iron, the sulfides and stuff, that helps drive that gold into solution. And I'm not super experienced seeing gold-bearing ore, but the clean white quartz is not what you want. You want this dirty quartz. And I think one of the reasons you don't find this as often in your tailings pile is because all those other pieces make it break apart much more readily. So when the glaciers were bringing it down, this is much more likely to get crushed up and smashed, releasing the gold, but not keeping intact to find in your tailings pile. Whereas this piece of quartz, which is pretty much pure silicon dioxide, nothing else in there, that's going to be a lot more solid and a lot more resistant to getting crushed as the glaciers are tumbling it and bringing it down from wherever it came from. But the question is, how much gold is in here? Here's a full gallon of dust all pulverized, and I'm wondering the best way to process it. Should I run it through the sluice or pan it all down? I think I'll pan it down. And my thinking is silicon dioxide is not really that heavy, so the quartz is gonna float off there pretty easily. It's gonna be pretty quick to stratify it and get everything in the bottom, and I'll be able to move more material faster. With the cleanup sluice, it's 1 teaspoon at a time, so I'm just thinking this will be a little bit faster and just as effective. So I think I'm gonna run this through my kitchen strainer just to make sure I get all the big chunks out first. That should be pretty quick. Look how red that is. This turns to red mud right away. Now that's just 2 handfuls I panned out there, and I can already see like black sand starting to form. So that tells me there's a lot of heavy minerals that are mixed in with this quartz. That's good. So what I'm gonna do is I'm just gonna kind of concentrate that. I'm gonna go down to, when I see the black sand, dump that out, and then I'll just kind of make a concentrate bucket to kind of do it in the final stretch of the cleanup. So that's been reduced to a little bit more manageable amount. So I'm just gonna pan that down. There's plenty of black sand and heavies in there. I mean, not a ton, but it's in there. I'm gonna be really careful with this because all those heavy materials are really, really fine. Like exceptionally fine. Really gentle with this. That's all the black material left, but you can see there's a lot of metallic material, and that's little pieces of the mighty mill. Those little chain clevises that flaked off. And this is really dense and locking together. It's really kind of hard to move. So I'm gonna use one of my magnets and go ahead and take some of the metal out. See, there's quite a bit. And what's left in there is probably sulfides and hematite and stuff that's not magnetic, but should be easier to handle now. And look at that, a little line of Minnesota hard rock gold. It's interesting, there's also a few garnets to be found in there. Garnets, again, are those metamorphic minerals. They're a high pressure, high temperature mineral. So that tells me there's a sign of metamorphism around the area, which makes sense. And there's this piece right here that's really weird. It kind of looks like molten metal. So I don't know if that's just some contaminants that was in the bag or something, but it's kind of heavy. But it's definitely not natural. So that's pretty cool to see. There is definitely gold from that quartz. Not a lot, and I can see why the gold rush in Minnesota never really caught on. It's a pretty hard squeeze for not a lot of juice, but still super cool. And there might be way better ways of extracting this super fine gold. Some people might use mercury. I'm definitely not going to touch mercury, but it is a slick way of collecting all that fine gold. The ball of mercury just kind of sucks up any gold that comes in contact with. Then you burn off the mercury and get a little ball of gold at the end. There's that one golden colored ball in there that looks kind of weird. Maybe that's from their processing of the fine gold. Whether they use mercury or not, I don't know. I know most places don't use mercury anymore, but some people still do. I just know I'm not going to use it. But I think it's super cool to see some of that hard rock gold. Thank you to Jason for letting me use that mighty mill. That thing's pretty slick. And thanks to Dean for giving me this gold ore. And thank you guys for watching. Come on back for the next one. Bye-bye.